There are four types of linear inequalities we're going to look at today. Okay, you've got your greater than, less than, your greater than or equal to, and your less than or equal to. Okay, along with those come the four different symbols. Okay, you're all familiar with these. Equal to's have the line underneath, and not equal to's do not. Okay, so when we're graphing them on a grid, a linear inequality, we have to use a different type of line based on whether it's equal or not equal. So for the not equal ones, we're going to be using a dashed line. So we make it dotted. Okay, for the ones that are equal to, we just use our normal solid line that we draw through there. Okay, we also have to shade it based on whether it's greater than or whether it's less than. So for the ones that are greater than, we're going to be shading above the line. So you see that here, and for the greater than or equal to, above. Okay, less thans, conversely, you'll see we shade below for both types. So here's an example of what those graphs look like for each one. Alright, so linear inequalities, you're relating two variables, so we're doing x and y now, to each other using an inequality symbol. Solution set is the entire region of the coordinate plane bounded by a line. Okay, so we're going to first graph our line, and then we're going to figure out the region on top of that. Okay, so from our lesson before, first step is to plot your y-intercept. So that's at positive 2 right there. Okay, then we're going to use our slope. So remember, this is a rise over a run. So negative 1 tells me to go down 1, right 3. Positive 3 is right. Down 1, 1, 2, 3. Okay, remember, up and left, same thing. Okay, but before we draw the line through it, you need to go back and look at your symbol, greater than. Okay, from our thing we just did, that means we're going to make this a dotted line, like this, with the arrows. Alright, and then it's greater, so we're going to shave it above. So anything in that region is part of the solution set of our line. Okay, you'll see down here it says choose a point in the solution set to test. Rather than do that, I just want to talk to you about multiple choice. Okay, usually they'll say which of the following points is in the solution set of blah blah blah. Okay, and then your answer choice would be like 0, 0. Okay, well that's obviously outside, that's not in the shaded part, so that'd be wrong. Okay, but then they'll give you 0, 2. That was our y-intercept. Okay, and that's on the line. When we draw a dotted line, the dotted line means that it doesn't count. That's not part of the set. Okay, so in this case, the point on the line would not work. If it was a solid line, if it was an equal to problem, then it would count. So it matters, that dotted line and solid line. Okay, so your answer, you want it to be well within this shaded region, something like 0, 10 up here or something like that. Okay, this one's just one of those special types. It's the x equals version. So if you remember from our last lesson over graphing, x equals is the vertical type of line. So x equals negative 7 tells me to go to 1, 2, 3, 4, 5, 6, negative 7. I'm going to plot a point there. Alright, then we're going to draw a vertical line through here. Okay, and this should be, it's equal to, so it should be a solid vertical line, not a dotted vertical line. So like that. I'll put some arrows on the end. Okay, the tricky part about this, why I wanted to show it to you, is because our words above and below don't work for vertical. There is no above and below. There's only a left and a right. So on these, you want to look at the x-axis and think of it like you were graphing on a number line. Well, less than is left, so greater than, which is what we have on this one, we shade to the right. So all of that. Alright, so the hardest ones here, they're going to make you solve for y first, then graph it. Okay, remember we can't graph from this form anyway, so we kind of have to solve for y. Okay, solve for y again means get y by itself. Okay, so first step that I would suggest doing over here is distributing the 3/4. 3/4 times 8 gives you 6x. 3/4 times negative 2 is negative 3/2 y greater than 6. Alright, now sometimes when you distribute a fraction, the fractions will just go away by the nature of what the numbers were. Okay, unfortunately that did not work for us this time, so we do need to cancel out this fraction. So I'm going to do that by multiplying everything by the denominator, by 2. So 2 times 6x is 12x. The 2's on this one cancel, that's why we're doing this, minus 3y. Greater than, and another 2 times 6 is 12. Okay, now it's in standard form, so we just need to get it in slope-intercept. So move your x term to the other side. Remember that these two are not like terms. Okay, a lot of times you see those numbers being the same and you want to cancel them out. But this has an x, this one doesn't, so keep them separate. Not like terms. Okay, divide by negative 3. And we get y is less than, okay, we divided by a negative. Whenever you divide by a negative and you're doing inequalities, you have to flip that sign over. Okay, it's the number one thing that's missed. Negative 12 over negative 3 is positive 4. 12 over negative 3 is negative 4. Okay, let's go over here and graph it. So 1, 2, 3, 4. And then remember our slope is a rise over a run. This one doesn't have a denominator, but we can make anything have a denominator if we put it over 1. So that's a positive 4, 1, 2, 3, 4, and right 1. Up 4, right 1. Do it again. Okay, look back at your symbol before you graph the line. Regular, less than. Consult that tree map we made, and you'll see that we should be graphing a dotted line, and that we should be shading below. Okay, it's the steeper the line gets, the harder it is to tell what's below. Okay, but the graph is always slanted a little bit. So if it's slanted to the right, this is the below section. Okay, if you're taking notes on your piece of paper, which you should be, you can physically turn your paper to the right until that line is horizontal, and then you'll be able to tell what's above and what's below. Okay, if the line had been slanted to the left, if it had been a negative sloped line, then you just turn your paper to the left, and then you'll be able to tell what part's above and what part's below. Okay, it's really only an issue with these more steeper sloping lines than the more shallow lines. Okay, if you want to give yourself a challenge, pause the video and give this one on the right a try on your own. Last one we're going to do together is this word problem. So we're running a carnival, we're charging $4.50 for adults and $3 for children, and we need to make at least $135. Okay, we need an x and a y from this problem. So our variables in this case are going to be adults and children. So rather than using x and y, I'm going to use a and c. So the equation, notice up here it says write and graph. We can't graph until we have an equation to graph from. So I'm going to write the equation first. 4.5 times the number of adults that come, plus $3 times the number of children that come. Okay, and this word at least, this is a code word. Okay, that means we need to make 135, but we would love to make more than that. So at least equal to 135, but we'd love it to be greater than. So greater than or equal to is what at least is code for. Okay, so greater than or equal to 135. Now, you get to pick, you still have to solve it for y to be able to graph, but we get to pick what do we want our y to be. Okay, I'm going to pick C just because it's in the spot that y usually is. Okay, you can easily pick A and it will work out. Your graph would just look a little different than mine. So we move the A to the other side. That gives me 3C is greater than or equal to negative 4.5A plus 135. Divide everything by 3. Okay, do not flip the sign over. This is a positive 3 on the bottom, so we keep it the same. Greater than or equal to negative 4.5 over 3 reduces to negative 3 over 2A, and 135 over 3 is 45. So when I go over here to plot this, I plot my y-intercept. So I'm going to go by 5s on my graph, so 5, 10, 15, 20. Whenever you change the scale, make sure to label it. Alright, so I need a point right there at 45. Okay, now if we go by the same scale down here, which usually when you scale something you want to do it for both the x and y axis. That means that for our slope we don't have to count like 1, 2, 3, 1, 2 and be like in the middle right here. Okay, we can actually count just 3 full units. 1, 2, 3, 1, 2 and put a point there. Okay, that's like doing negative 15 over 10, which is just an unreduced version of negative 3 halves, but it's still the same thing. Okay, so let's keep on going. 1, 2, 3, 1, 2. And one more time. We'll get us down here. Alright, now normally just regular lines we keep going. Okay, but we don't on this one because we cannot sell a negative amount of tickets. Okay, 0 is the least amount we can sell. Okay, so any of these quadrants that include negatives, which is all 3 of these over here, okay, we have to just leave out. Our entire problem is going to occur in quadrant 1 on this one. Okay, you notice we have an equal to, so we're going to connect that with a solid line. And it's greater than, which means that all this stuff out here is going to be the shaded part. Alright, let's answer this question right here. If 25 child tickets are sold, how many adult tickets must be sold? Alright, so remember, child was our y value, so that means that these are the child tickets. These down here must be the adult tickets. So if 25 child tickets are sold, that's about right here. Okay, how many adults are sold? And it looks like it's right on 15. Okay, but I kind of ballparked this line. It might not be perfect, so let's not assume, but we should expect our answer to be close to 15, just by looking at our graph. Okay, the way you get an exact answer, I'm going to go all the way back up to this original equation I wrote. I can plug in 25 for C in that equation. 4.5a plus 3 times 25 greater than or equal to 135. Okay, I know that 3 times 25 is 75, so if I subtract 75 from both sides, I get 4.5a greater than or equal to 60, then divide by 4.5, and you get a is greater than or equal to 13.3 repeating. Okay, so you got to think real world again in this situation. It's impossible to sell a third of a ticket. Okay, so how many tickets do we have to sell? Normally, in math, we round that down to 13, but that doesn't work for us in this situation, because if we only sell 13 adult tickets, there's that extra third that we really needed to get to our 135. Okay, so 13 is actually not going to be enough, so in this case, we have to say that we have to sell 14 adult tickets. You have to round up to cover your expenses. Alright, you see that that is pretty darn close to the 15 we guesstimated just by looking at our graph over here. Alright, thanks for watching.